Hello. So today we will look at Python dictionaries. Dictionaries are key-based mappings, key-value pairs. So let's jump right in. Here we are again on Google Colab. Let's create a dictionary. Dictionaries use curly braces. Let's do an example. Pirate. Now, curly braces, Captain. Now, important, colon, Luffy, then comma, no, not a string, bounty is an integer, comma, ship. So this is the basic syntax of a dictionary. We have curly braces and then key value pairs separated by commas. This is one key, captain, with a value, a string, and they are separated by a colon. So every key value pair is separated by a colon and each key value pair is separated by a comma. All of this inside curly braces, and then this is assigned to a variable. Print pirate. The spacing was just so it's more readable. We could have done it like this without the spaces. And this still runs and prints the same dictionary. This is the same dictionary with key value pairs separated by commas and the key value separated by a colon. It's just that this, I think, is more readable. So accessing values, instead of indexes, now we are using keys. So for example, let's print pirate captain. Bounty. Now we're in this here, Luffy, and this returns the value assigned to this key, and this prints the value assigned to this key. So no matter how long, huge, thousands of key value pairs this dictionary might have, when we access a value by its key, Python does the searching for us, goes and searches for this key and returns the associated value. And it does this very quickly because internally dictionaries work very fast. It doesn't go one by one. It knows where bounty is because internally it's like a hash table. To add values, the dictionaries are mutable. We can add data after the creation. So this dictionary object is created, and to add a value, we do this syntax. This will be the key, and we assign a value like this. So when we see what's inside the pirate dictionary, now it has the key value pair Cook Sanji. And if you can notice here, I did not print, I just put pirate, hit the run button, and when this Google Colab or Jupyter style notebooks, they output what contains in this dictionary. So like we can add values, we can also modify values. For example, ship, now it's equal to for example, and then we see what pirate has. Now the ship is 1000 sunny and not going merry. Now, what happens if we try to access a key that does not exist? Doctor, we have a key error, doctor, because there is no key value pair in which the key is this key. So this is where a built-in Python method comes into play with get. So print pirate doctor. So we already saw this does not work. But if instead of trying to access the key value pair with this square bracket notation and the key does not exist, it returns this error, right? But if we use the get method built into Python dictionaries, and since it's a method we use parentheses, now we try to access doctor. Now we run it, and since it does not exist, it does not break and screams at us. It simply returns the non variable or non-type value. Dictionaries can also be looped through. So looping through dictionaries would be syntax like this example for key, and this is a variable I made up in pirate. Now we run indented code, print key. So it loops through the pirate dictionary and prints every key. So by default, this loop through the dictionary loops or walks through the keys. If there is another method built into dictionaries called for dot items, built-in method item, so this will return two values and then they will get assigned to these two variables I made up. So it cycles or walks through the dictionary and it returns the key value pair each time. So let's run this. And here we go. Captain Luffy, bounty 3,000 sheep, 1,000 Sunny, and Cook Sanji. Now to check if there is a key in a dictionary, we ask Python like this. If captain in pirate print captain found. Captain found. If doctor in pirate, it does not print captain found because this returns false. Not found. Captain found. So at this point we have two important data structures, lists and dictionaries. Lists are ordered and position based, good for sequences, and dictionaries are key value pairs. So this is where things start becoming very powerful, because we can combine structures and then we can have, for example, lists of dictionaries. And let's see an example. All right, so let's start with the list. Square brackets, and then inside the list we are going to have dictionaries, so curly braces, and then name column Luffy, comma bounty column 3,000 for now. Comma separated, because in our lists each object is separated by a comma, right? So let's just copy and paste this a couple of times, and Zoro, and let's say Nami. And there we go. Now we have a list of dictionaries. So here we have this very common data structure, a list of dictionaries. So now let's loop through it. For member in crew, here let's print member name. Here we go. And for example, print bounty. This data structure, these patterns appears everywhere. APIs, databases, web applications, game systems, automation tools. Structured data is one of the foundations of programming. So now we are starting to combine multiple concepts together. We have a list containing dictionaries, and this dictionary stores structured data. This is already very close to how real programs organize information. Now let's do another little example. Let's suppose we want the total bounty of each crew. So we walk through the list, access each dictionary, extract each bounty, and accumulate the total. So let's do that let's start with total equals 0. Then let's loop through in crew. Now let's access the bounty. Now let's add this to the total. Now let's assign this to total again. Now let's, at the end of this, print total. Run all. So here we go. So this pattern is very important. We loop through each one, we extract some value, then we do something to it, and then we accumulate it somewhere. And then in this case, we just printed it out. Okay, so with this, we will finish this video, Dictionaries. Hope you liked it. See you on the next one. Thanks. Bye.